Hello and welcome back. We've just been looking at percentages, and we were taking percentages of numbers, and we can also work out, if we're given two numbers, we can figure out if one is a percentage of the other one. And this is actually something that we did before when we were looking at rounding ratios and percents. In that homework, we actually calculated some percents, and we'll see exactly the same thing here. So if 39 is going to be some percent of 52, we want to figure out what percentage it is. So for the moment, I'm just going to say it's p percent. I'm going to give it a name so that we can work out what this is. So if I say 39 is p percent of 52, that means p percent times 52. This is p percent of 52, and that's going to equal 39. So I want to solve for p percent. But p percent is a percentage, and it's not necessarily a straight number. So to turn this into a number, I have to take the percent and turn it into divide by 100. When we have this, again, I'm taking p over 100 and I'm taking it times 52. I don't want that times 52 there. So to get rid of the times 52, I have to divide by 52, and whatever I do to one side, I have to do to the other. So those will go away. What's left over, p divided by 100 is equal to 39 divided by 52. And again, if I'm dividing by 100, I don't want to divide by 100. I want to get rid of it. The opposite of division is multiplication. So I'm going to multiply this side by 100. I'm going to multiply this side by 100. If I multiply by 100 and divide by 100, those go away. And left with p is 39 over 52 times 100. And if we plug this into a calculator, we're going to get 75. And this is, in fact, 75% because we've multiplied by 100. So 39 is 75% of 52. Let's go through one or two more. So we've got 100 is some percent. Let's say p percent of 88. So what I'll do is p percent of 88. This is just p percent times 88, and we should get 100. Well, p percent, that's p divided by 100 times 88 is equal to 100. And again, we'll go through the same steps. I'm multiplying by 88. I don't want to be multiplying by 88, so we'll divide everything by 88. After we cancel out the 88s, I'll get p 100ths is going to be equal to 100 divided by 88. And I don't want to divide by 100 here. I want to get rid of that. So the opposite of division is multiplication. So I'm going to multiply by 100. I'm going to multiply by 100. Whatever I do to one side, I have to do to the other. Multiplying, dividing, cancel out. So p is going to be 100 88ths times 100. And if we plug that into a calculator, and we will just round to the nearest tenth, we get 1.136. And again, this is our percentage. This I had to plug into a calculator. I couldn't do that in my head. So we see that p up here is going to be 113.6. This is rounded to the nearest tenth. Let's do one more. 5 is some percent of 625. So again, I'm just going to take p percent of 625. This is going to be p divided by 100. Times 65. Sorry, times 625. P percent of a number. We know that that's going to be 5 from our statement up here. So this is going to be 5. So what I'll do is I will divide both sides by 625. Again, I'm multiplying by 625. To get rid of that, I need to divide by 625. And whatever I do to one side, I have to do to the other. So I have p divided by 100, 5 divided by 625. And then, again, I'm dividing by 100. The opposite of division is multiplication. I have to multiply by 100 to cancel out the dividing by 100. Whatever I do to one side, I have to do to the other. So p is going to be 5 divided by 625 times 100. And I should get 0.08. And this is 0.08%. This is already a percent because I'm multiplying by 100. So this p, this is going to be pretty small. 5 is going to be 0.08% of 625. Less than 1% of 625, which makes sense. 5 should be 1% of 500. So it's a little bit bigger than that. So another phrase that we can see come up is p% more than some number. And this isn't p% of a, this is p% more than a. So if we think about this, we can go through an example sort of how we would expect it to be. So 10% more than 48. What does this mean? Well, it would mean that we'll take 48 and we want to add 10% of it. So we want to take 10% of 48 and then add it to 48. So we have 48 and then we want to increase it a little bit. How much? By 10%. So we take 10% of 48 and then add it back in to make 48 just a little bit bigger. So if I take 10% of 48, that's the same thing as 10% times 48. 10% is 0.1. So 0.1 times 48 is 4.8. So if I want 10% more than 48, I'm going to take the original number, add 10% to get 52.8. So again, we're just taking this number, we're taking 10% of it and adding it back to itself to make it bigger. So we can do this formally as well. p% more than a. The way this works is I want to take a and I want to add a little bit to it. I'm going to add p% of a back to itself. Well, we can simplify this. p% times a, I don't want to take a percent times a, I want to take a number times a. So this is going to be p divided by 100 times a. And here we can use something called distributivity, distribution, and I'm going to pull this a out, and I will be left with as simple a formula as possible. This is going to be a times 1 plus p over 100. So when we look at this, what's happening here? We're taking a and we're taking it times 1 plus a bit more. This 1 is the same number as 100% that we saw before. P divided by 100, this is the same thing as p%. So what we're doing is we're taking a, we're taking 100% of it plus a bit more, p% of it. So we're taking a and we're increasing it by a little bit. We have to start with a, which is the 100%, and we're increasing it just a little bit more by p%. This is all the parts here. Let's use this formula. What is 12% more than 63? So again, I'm going to be taking, if we come back up to our formula, a here is the number that we're increasing. We want 12% more than 63, so a is going to be 63, and this 12%, that's going to be p% here. So what I want to do is I want to take 63 and I want to increase it a little bit more. We're going to take 100% of it plus a little bit more. Cool. So what we can do is we can start plugging some things into a calculator. So I will take 63 and I'm going to take it times everything in the parentheses. So order of operations, says that we have to do everything in the parentheses first. So I'm going to ignore the 63 for a moment. That's why I wrote it there. I'm not going to do anything to it. And then I have 1 plus 12 divided by 100. First things first, and order of operations, addition comes last. Division comes before addition. So I'm going to take 1 plus 12 divided by 100. I can plug that into a calculator and get 0.12. Again, divided by 100 is as simple as moving the decimal place over. And now I have some addition in here, which is pretty easy. So 63 times 1 plus 0.12 is 1.12. So far, so good. And then I can take a calculator and I can multiply this out to get 70.56. So the answer, what is 12% more than 63? 70.56. Let's do another example. What is 25% more than 76? So again, I have 76 and I want to increase it by a little bit. I'm going to take 100% of it and add another 25% of it. So again, 25% is the same thing as 25 divided by 100. So this is going to be 73 with order of operations doing what's in the parentheses first, and again order of operations doing the division first. So 25 divided by 100 is 0.25. Now I get to add those. It should be 76, not 75. 1 plus 0.25, 1.25. And if we plug this into a calculator, we will get, I did this beforehand, 95. So what is 25% more than 76? 95. Cool. And even here, we can rearrange some things. So we can find P2. So here's a question. 20 is P% more than 16. What is P? So here we're just going to have to use our formula and see what sort of pops out here. So according to our formula, 20 is P% more than 16. So here's our phrase. P% more than 16. If I take 16 and I increase it by P%, I'm going to take 1 plus P divided by 100. Okay, so again, this is 16. I take 100% of it plus a little more. And we know that we get 20. So here, we've got 16, and we're going to take 100% of it plus a little bit more. The way that I'll simplify this is I have to work from the outside in. P is all the way here on the inside, so I have to get to it. So I'm multiplying this whole thing by 16. I don't want to be multiplying by 16. I've got to divide by 16. So multiplying by 16 divided by 16, they cancel out. And I'm left with this over here. So 1 plus P over 100 is 20 divided by 16. Again, what I can do now is I want this P by itself, but I'm adding 1 to this thing, and I don't want that there. So I'm going to have to subtract 1 from both sides. So I'll subtract 1, subtract 1. If I add 1 and subtract 1, they go away. So P divided by 100 is going to be equal to 20/16 minus 1. Let's keep going. We're nearly there. I'm dividing by 100. I don't want to divide by 100. I want to multiply by 100. So P, after I cancel the 100s, is going to be 20/16 minus 1 times 100. If I plug these things into a calculator, 20 divided by 16 is 1.25 minus 1 times 100. 1.25 minus 1 is 0.25 times 100. Plugging that into a calculator is 25. So what is P? P is 25.